Okay, page 12. Okay, this is number 19. Amy's family went to an amusement park while they were at the beach. She decides to ride the Ferris wheel so she can look at the ocean. She's disappointed to find out that the 100-foot building blocked her view for part of the ride. Amy's height in feet above ground as she travels around the Ferris wheel can be modeled using the following equation. Okay. H of t equals negative cosine 2 pi over 3t plus 70. So this is basically the 70 is the average height for the Ferris wheel, but it's going to start on the ground. So that on the ground means that it's going to start off 10 feet above ground, but then it's going to go up to 130 feet and it's going to come back down around. Okay, and we just basically have to figure out how long will it take for Amy to see over the building. So think of this as the height of the ride at any time. So you're trying to figure out when is Amy going to be able to reach 100 feet, so that she can actually begin to, look over the building that's blocking her view. So let's just start off with replacing h of t with 100, because the building is 100 feet tall. Okay, so we're just working through this equation here. 100 equals we want to find out how long will it take for Amy to be 100 feet above ground, because that's exactly how high she wants to be, so that she can have at least a bit of time when the Ferris wheel is above 100 feet, where she can actually have a view of the beach. Okay, so now it's just a matter of trying to get this 2 pi or cosine 2 pi over 3t by itself. So what would you do first? Subtract 70, right? And then we can divide by negative 60, and then we can talk about what to do with this cosine. Okay, so subtract 70. Okay, what's next? Divide by negative 60. Negative 1/2. All right, 60s cancel out. 30 divided by negative 60 is negative 1/2. Okay, now this seems a little bit strange here. I'm going to rewrite this, having the cosine on the left. Now, I know we haven't seen something like this before, so I want to walk this through with us. We're trying to solve for t, right? I want to solve for t. This cosine is kind of getting in the way. I want to move that cosine. So the way we move cosine or trig function to the other side of the equation is we use inverse. So we say this. Sorry, not cosine. 2 pi 3t is equal to, okay, we shift that cosine over, it turns into inverse cosine. And now we have something that we can transform on this side. Okay, so if you look back, the unit circle, when is cosine of theta equal to negative 1/2? 2 pi over 3, right? 2 pi over 3. We're practicing that from yesterday. Right, second quadrant is when cosine is equal to negative 1/2. So this is nice, right? If I can just, oops, I messed out on the pi here. If I want to solve for t, I can just divide by 2 pi over 3. Dividing by a fraction is the same thing as what? multiplied by the reciprocal. So 2 pi over 3 times 3 over 2 pi. Pi's cancel out. So then tells us that t equals 1. What does that mean? That means 1 minute into the ride, Amy will finally be high enough where she can look past the building and actually see the beach or see the ocean. Okay, part B, how long will it take for Amy to reach the top of the ride? So how high is her highest? What's the highest moment? Or how high will she be at the top of the ride? So this 70 tells us that's the average height, but then this negative 60 tells us that's the amplitude, right? So what can we say? 70 plus 60, 130, right? So 130 feet is top of the ride. Right, so replace h of t with 130. Back to the equation, and now we're just going to solve for t just like before. Subtract 70, divide by negative 60, inverse cosine. Okay, same process, just a different number in place of h of t. Okay, you guys with me? Okay. Subtract 70. Divide both sides by negative 60. $60 divided by negative 60 is negative 1. Okay, let me rewrite it in where the cosine is on the left side. Okay, I want to solve for t. I want to get that 2 pi over 3t by itself. I want to move that cosine. So when we move cosine, we, in a sense, involve inverse cosine. So 2 pi over 3t. Now that it's by itself, shift that cosine over to the other side. So in other words, we're asking, when is cosine of theta equal to negative 1? When is cosine? Say it again. Cosine of theta is equal to negative 1 when theta is pi, right? You guys okay with that? Okay, 130. It comes from what we know about amplitude and our d value. So this 70 tells us that this equation has been shifted up 70 units. And then that 60 is the amplitude. So the ride is going to go 60 feet above 70 feet and 60 feet below 70 feet. So the highest it's ever going to go is going to be 130 feet. Okay. Yeah, glad you asked. Any questions here? Okay, so now we understand cosine is equal to negative 1 when theta, or when t is equal to pi. So I want to solve for t. I want to move that 2 pi over 3. Dividing by 2 pi over 3 is the same thing as multiplying by its reciprocal. If I do 3 divided by 2 pi, the pi's cancel out. I'm left with 3 over 2. 3 over 2 is 1.5. So that means 1.5 minutes into the ride, the Ferris wheel is going to be at the very height of its ride, of its ride, and then after that, it's going to start coming down. Okay, how long into Amy's ride will the building again obstruct her view of the ocean? So we know that the first time it hits 100 feet is going to be when cosine is -1/2, which is 2 pi over 3. So when's the next instance that inverse cosine is going to be -1/2? Where else is cosine negative? Which quadrant? Quadrant 3, right? So 2 pi over 3 is the cosine for in quadrant 2. Quadrant 3 would be what? 4 pi over 3. So I'm not going to redo the entire problem. I'm just taking at part A, understanding that the first time cosine, inverse cosine is going to be 1/2. -1/2 is 2 pi over 3. But then the ride's going to come back down again. It's going to hit this value again at 4 pi over 3. We divide both sides by 2 pi over 3. Same thing as multiplied by the reciprocal. Threes cancel out, pi's cancel out. 4 divided by 2 is 2. So 2 minutes in. Ferris wheel is going to descend down to 100 feet, and then after 2 minutes, she's not going to see past the building anymore. Okay, questions there? All right, number 20. Area of an isosceles triangle can be found using the formula 1/2 x squared sine theta. I'll put that here. Where x is the length of the leg and theta is the vertex angle. If an isosceles triangle has a leg length of 4, so that's the x value, right, when x equals 4, then what measure for the vertex angle will produce an area of 4? So we're looking for theta when the area is 4. So we'll start filling in our equation and see how inverse can help us solve for theta. Okay. Replace a with 4, replace x with 4, and then we'll see where this takes us. 4 equals 1/2 times 16, because 16 is 4 squared. 16 times 1/2, or 16 divided by 2 is 8. Okay, what can I do this to get sine theta by itself? Divide by 8. So now this looks familiar, right? 1/2 equals sine theta. In other words, sine of theta is equal to 1/2. So when is sine equal to 1/2? Pi over. Oh, wait, no, that's right. Oh, the pi over 6. Okay. Yeah, that's it.
Do you have a pen or pencil?
Mm-hmm. Flip back to page 11. Anybody still need this page? Let me do one of each type, and then I'll let you guys finish out the rest, right? So that you guys have a review over each type. So page 11. Let me do maybe 4 or 5 problems with you, and then have you guys finish off the rest. So I'll do number 1 with you. Let me do number 8 with you. I'll do number 13 and 16, okay? That way you will see all the different varieties, and then you can, so I can refresh your memory with all the steps. Okay, starting with number 1. Arctangent of -1, we always like to rewrite this in a form that feels more familiar. Inverse or tangent of theta is equal to -1. Remember that we're talking about principal values. Tangent is first and fourth quadrant. Sine is also first and fourth quadrant. Is cosine, that's a little bit different. Cosine is first and second quadrant. So where is tangent equal to -1? Yep, 7 pi over 4, but we need to make an adjustment. Good, -pi/4. All right, look in the unit circle. Unit circle tells you 7 pi over 4 is fourth quadrant, but we need to make that adjustment. Good. Okay, all the other rest of these are going to kind of follow that pattern. Let's look at number 8. Cosine of inverse tangent of -3. So first things first, we always pay attention to the inside first. Get that written out. Tangent of theta is equal to -√3 over 1, if that helps you to put that denominator below. Okay, so you look at unit circle here. When is tangent equal to -√3? Yeah, it's variation of pi over 3, right? We know that pi over 3, we're going to have √3 over 1, but it's going to be negative. Maybe you're looking at 5 pi over 3, but we need to make an adjustment. So -pi over 3. So we're not done yet. So we're going to say -pi over 3. But now we got to turn around and figure out the outside. Yes.
Tan is y over x, right?
That's right. Tangent is y over x.
So wouldn't it pi over 6?
So look over here. All right, yeah, you got it. Okay, so if it's cotangent, then cotangent, that'll be correct. But here, tangent, we're going to look at that pi over 3. Okay, variation of pi over 3. Now, careful, we're not done yet. That only figures out that bracket. We still got to turn around and ask, what is cosine of -pi over 3? Okay, two-step process here. So look at your unit circle. What's cosine of -pi over 3? Yep. Cosine of pi over 3 means I'm going pi over 3 in this direction, which is going to land me in 5 pi over 3, right? 1/2. Okay. Everybody okay with that type of variation, right? You always get all the information that you can from the bracket or the parentheses, and once the dust settles, then you can do that final part with what the outside trig function is asking for. Okay, number 13. Tangent of inverse sine of 3/8. This is not going to be a special unit circle angle, but we can create a triangle in Pythagorean theorem to find our ratio that we need. Okay, so in other words, it's saying create a triangle where sine of theta is equal to 3/8. Okay, which quadrant this is going to be in? First, right? If it's positive, it's always going to be first. Doesn't matter which trig function. Let's create our triangle. Okay, where does the 3 and 8 go? Opposites over hypotenuse. Okay, a squared plus b squared equals c squared. (64 minus 9, 55). Not going to come out to be a perfect square, so just leave it as the square root, √55. Okay, so now we have the triangle in front of us. Now we can make the decision. What is tangent of theta going to be? 3/55, yeah. Okay, 16. Any questions there, 13? Same process as 13. We just have to adjust for the fact that we're going to have some variables left because the variables are not going to go away. So, okay. All right, build from the inside out. Arc tangent of 3x, that's saying, what would it look like if tangent of theta is equal to 3x? If you don't see a denominator, put a 1 below to help you see the numerator, the ratio portion. Now with variables, you're always going to put in the first quadrant. Okay, so tangent of theta equals 3x over 1. Let's build our triangle. All right, where does the 3x go? Where does the 1 go? Opposite over adjacent. Okay. Now when you go through Pythagorean theorem, make sure you don't just make it 3x squared, that you're doing parentheses 3x squared, right? The 3 is also being squared, not just the x. The hard part is trying to get this triangle figured out. Once you get that triangle figured out, then you just do SOHCAHTOA with the outside trig function. Okay. What's cosine of theta? Good. You don't have to rationalize. You can just leave in whatever it gives you. Okay. Seems like yesterday you were pretty good with this, so hopefully today you'll just feel like review. And hopefully it won't take you the full period, but after about maybe 10 or 15 minutes, I'll put the answers up so you can check it. I'll come around and check you off for page 11 and 12, and we should be done before too long, okay? I'll come around in a few minutes to see if you have any questions, but. Mm-hmm. Cosine is first and second quadrant. If we see a negative cosine, it's going to be second quadrant. sine negative. Right, we have to make an adjustment. Principal values, this is negative 2. This is negative 3. Negative 4. Oh, negative 1 over 3. Okay, no, sorry. It should be a positive one. Negative 5 over 4. Negative 1. Mm-hmm. Mm-hmm. Okay, so tangent of 5 pi over 4, that's in the third quadrant. Tangent is y over x. The root 2 over 2, root 2 over 2 cancels out. We're left with just 1. So now we're asking, when is sine equal to 1? Sine is equal to 1 in the first quadrant, or actually pi over 2. Let me show the bottom half for those who are already wanting to check. I'll shift this back to the top for those who need it. So.
17.
Yep.
Why can't you distribute the square root and get 1 minus x squared plus 1 and just cancel out the ones?
Gotta be careful though. When you see x minus 1 squared, we don't want to take a shortcut that we can't do.
Oh, because you have to.
Gotta
FOIL
FOIL,
it, right?
yeah. So I mean, you can FOIL it out and make it a little bit cleaner, but it's okay. You can just leave it in this form and it's fine. Yeah.
Okay, thank you.
So it does clean up a little bit more, but I don't think it's worth the trouble. So I'll leave it like that. Let me check your pages.
Can we talk?
All right, have a good break.